The question is, the function showed in the pseudocode below is invoked as height of root to compute the height of a binary tree rooted at 3-pointer root. So you have to fill b1 and b2. So the function is int height of 3-pointer n. If n is equal to null, return -1. If n's left is equal to null, if n's right is equal to null, return 0, else return b1. Else h1 is equal to height of n's left. If n's right is equal to null, return 1 plus h1. Else h2 is equal to height of n's right, return b2. So the options are option A, b1 is 1 plus height of n's right, b2 is 1 plus max of h1 comma h2. Option B, b1 is height of n's right, b2 is 1 plus max of h1 comma h2. Option C, b1 is height of n's right, b2 is max of h1 comma h2. And option D, b1 is 1 plus height of n's right, b2 is max of h1 comma h2. So first, height of a binary tree is defined as the maximum distance from the root to the leaf. So the longest path from the root to any leaf is the height of a binary tree. So now let us just go through this code and analyze it. So the function height is called with a parameter 3-pointer n, which is the root. So if there is no root, you will return -1. If root's left is null, basically if this is the scenario, the tree is of this form. So there is no left child. And if n's right is equal to null, means there is only one node. There is no left child, no right child. Then you will return 0, the height is 0. Else return b1. So for this scenario, you have to return the height. So the height is the height of this subtree plus 1, because you are adding this edge to the height of this subtree. So b1 will be 1 plus height of n's right. So b1 is 1 plus height of n's right. It can either be option A or option D. Now let's go on. Else, that is if n's left is not null, h1 is in this scenario, the tree can be of this form, or it can be no right subtree. Let's see that. So h1 is the height of n's left. So the height of this subtree is h1. Now if n's right is null, that is if this subtree does not exist, then the height is return 1 plus h1. That is the case here. Else, that is if this is the case, that is there is a right subtree, h2 is height of n's right. So this is taken, this is noted as h2 and return b2. So as I said, the height is defined as the longest path from the root to any leaf. So in this scenario, for finding the height of the tree, we need to know the maximum of h1 and h2, since we are looking for the longest distance, and add 1 to it. So if h1 height, the height of this subtree is more, then you add this plus 1. If the height of this subtree is more, then you add h2 plus 1. Therefore, the b2 is 1 plus max of h1 comma h2. So b2 is 1 plus max of h1 comma h2. So option A is the right answer.